Hey there guys, so we're looking at the inverse exponential function, which will then be an introduction to the log functions because we need log to solve exponents. And typically here when we swap x and y is the exponent and we'll need to use log to do that. So let's go through the rules again. We are going to swap x and y. We're then going to make y the subject of the formula. Then we're going to draw both the original graph and the inverse graph and show how it's a reflection about the line y equal to x. Okay. So let's start by calculating the inverse equation by swapping x and y. So I'm going to invert this equation. This is going to be my x and that's going to be my y. So I have x equal to 2 to the power of y. Perfect. Now I just need to make y the subject of the formula, and I'll do that by using log. So the rule for log is that we take the exponent, which in this case is y, and we make that equal to log of, now this subscript here, this is going to be the base, and it's always the same base that is here. Okay, so the 2 goes there, and then as a regular number or letter, we're going to put the x over there. Okay, so y is equal to log 2x. Okay, 2 is written small, and then x is written like the same size as the rest of the other letters. And so we can conclude by saying therefore the inverse function is equal to log 2x. Okay, and that is it. That's basically how you get the equation for an inverse exponential graph, which is a log graph. Now to draw this log graph, we're going to make use of the table method, a very reliable method to draw. And so I'm going to substitute all my x values into this function and work out the y values. You can see I have the same table for the inverse, but notice I already swapped the x's. So these x values, I wrote them as y values. And then whatever y values we work out here, I'm going to substitute that for the x values. Okay. So negative 2 to the power of negative 2 is a quarter. And 2 to the power of negative 1 is a half. 2 to the power of 0 is 1. 2 to the power of 1 is 2. And 2 to the power of 2 is 4. Remember the same values I'm substituting here, I'm just swapping the x's and the y's. Basically the same thing we did for the equation. We swapped x and y. So that means everything swaps. Cool. Now I just plot in the points. Okay, so I'll start with the first point, which is negative 2 and a quarter. That should be about, okay, so a quarter is very low, it's close to the x-axis. Then negative 1 and a half, that should be in the middle of 0 and 1. Then 0 and 1, that's the next coordinate. 1 and 2, and 2 and 4, so up there. 2 and 4. And we're going to do the same thing for the inverse, but let me first draw a nice curve. Going through all the points, there we go. That's a nice curve. We're going to do the same thing for the inverse. Let's start plotting these coordinates, a quarter and negative 2. I actually just need the space here, so let's go a quarter and negative 2. And then a half and negative 1, 1 and 0, 2 and 1, and 4 and 2. Again, let's just draw a nice curve going through all these points. And there you go. We're also going to draw the line that represents the reflection, and that will be this line over here. Remember the equation to that line is y equal to x. And you can see this line acts as a mirror for the two graphs. Notice every point is being reflected. Right? The coordinate of this point over here we said it was -2 1/4. We got that because we said when x is -2, so 2 to the power of -2, we got 1/4 for that. And so the coordinates of this point here is 1/4 and -2. So it's basically the same coordinates but just swapped it out. And so this we find that if x is 1/4, so log basically reverses the exponent. You ask yourself, if the base is 2, right? 2 to the power of what is going to give me 1/4? And the answer is -2. So that's how you read log and exponents. Now, let's write down the domain and the range for each graph. Remember, they're just going to be like inverses of each other. So the domain for the original graph is all the x values. And the range for this graph is just the y values greater than 0. So all the y values greater than 0. But now if you look at your inverse graph, notice the domain is only the x values greater than 0. And when you look at the y values, we make use of all the y values. Y is an element of the real numbers. Can you see that this domain is almost a range? It became a range, and this range became the domain. So when we swap x and y, everything swaps. The domain and the range swaps, the coordinate swaps, the asymptotes even swaps. Let's have a look at what the original asymptote was. For the original graph, the asymptote was the x-axis. The blue line could never cross the x-axis, and so the asymptote was y equal to 0. But now, the asymptote for this green line is the y-axis, and the equation for that is x equal to 0. That's the equation for this vertical asymptote. And so everything swaps.